Hello everyone, welcome to FireGuard. They aim to revolutionize approaches to wildfire prediction and prevention via AI technology.
You may have seen recently on the news that there is increasing number of wildfires around the world, including one in Malvi and Greece in 2023. And UN predicted that the number of wildfires gonna increase by 50% by the next century. Australia wildfire was one of the worst in their history, with damages to people, forests, buildings, and released massive amounts of emission into the atmosphere.
So, traditionally, the main solutions to treating wildfires involves first responders intervening after the wildfire has actually caused destruction, and that includes water systems from trucks, helicopters. But this is a problem because it means that the destruction has already been caused, and this can be more difficult to treat. So, what we plan to do is use AI to try and predict the wildfire before it starts and before it causes that destruction. We have data that is readily available from weather stations based on a set of parameters, including wind speed, wind direction, temperature, humidity level, and dew point. The data collected based on these parameters can then be used to train our deep learning AI model. So after we obtain the data from the weather station, based on the various inputs, we can feed this in to train a multi-layered neural network, which will learn different weights and biases based on the parameters. At the end of the layers, an output will be passed out, and we can convert this into a probability that represents the likelihood of a fire starting.
Here is how we plan to train our AI model. Our model is trained on data from various weather stations in each region. To perform training, we first feed historical weather data into deep learning module, which output is prediction. We then use explainable artificial intelligence, which provides explanation if the weather factors we input to the model are significant. We believe the less the parameters model uses is better for accuracy, so we eliminate the least significant factors from our model and feed the modified set of data, which has less parameters, into the deep learning AI again. We then compare our new version of the model's prediction with the previous version. If our new version predicts with better accuracy, we will keep performing the loop, eliminate one factor at a time. However, if the new prediction is worse than the older version, we will return to the older model and stop the process. After that, we believe we have the best model based on the dataset on hand. So how is our model can be used in practice? Firstly, the weather station would collect real-time data corresponding to the weather factors that were decided to be the most significant for that particular area. Then, our offline model would analyze the data and output its prediction of whether the wildfire will occur. If the model predicts safe weather, we will return to the observation process again. On the contradiction, if it predicts a wildfire is going to happen, the weather station will automatically send a warning signal to both first responders and the households.
We wondered in what other situations our model might be useful. Our conclusion is that by fitting our model with slightly different weather parameters, it can be trained to predict disasters other than wildfires, such as earthquakes, tsunami, and flooding. However, our model is still far from being perfect at this stage. Weather stations collect only a limited number of weather parameters, which constrains the accuracy of our model's prediction. For example, one possibly important factor is the types of trees that the forest is made of. Fir is a well-known type of wood that can easily catch a fire, but pines are not. Another example is soil moisture. It may affect air humidity inside the forest, which may differ from the overall air humidity detected by the weather station. Other undetectable forest-specific factors, such as temperature beneath the forest cover, may also play a key role in the accuracy of predicting the wildfire. We try to avoid system failure. However, if our model is unable to predict a wildfire occurring, we came up with a backup system which uses an online machine learning model to predict the growth of the wildfire in real time once it has started, and will allow first responders to prepare their emergency procedures accordingly.
We are hopeful that in the future, AI will reduce the problems caused by natural disasters, including wildfires. Thank you for listening.